Hey there, in this video we're talking about private member functions and arrays of objects and pointers to objects in C++ object-oriented programming. And this is basically sections 13.11 to 13.12 in the Gaddis textbook. Now we're kind of getting towards the end of chapter 13, which is our initial introduction to object-oriented programming. So as usual in this video, near the end of the chapter, you get a little bit of a grab bag of issues here with these three items: private member functions and objects and arrays and pointers to objects. Of course, there's a lot more to learn about object-oriented programming in future chapters. We're going to add to the story. We're going to add to the story lots and lots of features, lots and lots of details about object-oriented programming. We're getting a pretty good package to begin with. So let's look at these three issues. Private member functions. So up until now, we've been saying you might as well make all of the member functions in a class. You might as well put them in the public section so that the application programmers have access to them. So, usually that's what's going to happen. But it's not the only option. You can put functions in the private part of a class, and we do that quite commonly if there's any function that's really for the use of the class programmer, and really they're the only one that needs to know about it. You might as well put it in the private section so that the application programmers don't worry about it. Again, when you put stuff in the private section, you're saying, hey, application programmers, don't memorize this, don't learn this, don't touch it, don't worry about it, right? And there's actually quite a few, times when that'll be the case. So a lot of classes have some private member functions for managing the data and managing the internal state. It's pretty common, honestly. So again, the whole point here is that a private member function would be for internal processing of the class, will not be used outside the class, will not be accessible to the application programmers. All right, so here's an example of that. Now in the last video, we had pretty much the same thing, pretty close. This contact info class to store one person's name and phone number, and the memory space is dynamically allocated, so you're not wasting even a single byte of storage to store the name and the phone number. Now, my one point of contention with version 1 in the last video is that they'd inlined the constructor and it had gotten too long, and 1, 2, 3, 4, 5, 6 lines or something like that. And that's really, to my taste, it's out of bounds for inline functions. You really want it, maybe 2 lines. So what they've done, as usual, is they've split it up into separate functions, separate smaller functions. We like that. We like things to be small. So what they've done here is they have the same private data, character pointer to where the name is, character pointer where the phone is. Again, both of those memory locations will be dynamically allocated in the constructor. But what they've done here is that the part that just makes memory for the name and copies the name characters in, they've isolated that in this one function that's new called initName. So, and again, we like this too. We like functions to be dedicated to just one job. So here's the function, initName does the one job of recording the name. Okay, you come in with a character pointer for a C string, and it allocates the right amount of space for that name, and it copies the characters over into that namespace. Great, that's one job, that's a well-defined function. And the new thing is that function's been put in the private part. That's a private function. So this is a function that's only going to get called from the constructor, as we're going to see on the next slide. The application programmer doesn't need to know about this, doesn't need to know this is happening, and actually can't access it. Okay, and similarly, here's a private member function called initPhone that just does the job of recording the phone number. So in comes a C string with the phone number from somewhere, and you dynamically allocate just enough space, right? And you copy all the characters over into that space, just deals with recording the phone number. Those are good functions, and I'm happy to have those functions inlined because they're only 2 lines long, right? That's usually my standard. 1 line, 2 lines, that's okay for inlining in the class declaration. No longer than that. So I'm willing to accept. And they're private. Now, here comes the public part. And of course, the constructor, I guess I'd say almost always needs to be public so that the application programmers can actually make one of these things. So just like before, the constructor takes 2 arguments for name and phone number, and now it's just 2 lines long. You call initName to record the name. You call initPhone to record the phone number. I guess there's a typo there, right? That should have been P, and we're just realizing that. The other thing, I guess the other thing I would improve here is I'd wipe out the comments. Again, I never write one comment for one line, one comment for one line. I can just read the line. Of course, I'm initializing the name. That's what it says right there on line 28. So personally, I would also rip out the comments and just have legitimately 2 lines of code there for the inline function. And I guess that has to be a P there on line 31. I hope the book has that correctly. Now here is the destructor. The rest of it's just the same. So here's the destructor, of course, that needs to deallocate, delete the array that you made for name and the array that you made for phone dynamically. So of course that's in the destructor, we knew that. And then here's the 2 accessors. Okay, so I really want to test this preferred version of the contact info example that's in the book here. So I have opened up the lecture code that comes with the book, chapter 13, in the folder Contact Info version 2. And I think there's a couple interesting kind of details or wrinkles about this example that I'm interested in working through here, actually. So one thing I noticed is there's only one file in this folder. There's contactinfo.h, and they actually made every single function inline, so they don't need an implementation file, contactinfo.cpp. So that went away. Now the other thing is there's also no application file. There's no actual test driver application file here. So that makes me start to suspect that maybe in this one case, the book authors didn't test this properly, which makes me a little bit uncomfortable. Okay, well, we'll see how that works out. So I certainly need an application program. So let me go over, here's the rest of the chapter 13 folder here. Let me go into Contact Info version 1, and I'll just take the test driver out of here. Okay, add that over there. Okay. And now I need to make, this. It is a multi-file program, so I need to make a project in my IDE of choice. Okay. So as usual, make a new project, console application. Call this test contact info. Again, the only point here is just like, can we make a contact info object? Does it work properly? That's all we're doing here. Not even going to have any user input on this. It's going to be hard-coded. So save that in the same folder in contact info version 2. Good. Okay, so there's my project file. Just showed up. The dev file, of course. So I don't need this main function here. I mean, I could have written my own test driver. Go over the projects tab, remove the main.cpp, don't care about that. But what I do need to do is I need to add the existing files, the header file and the application file. Okay, so I can look at contactinfo.h. We've seen this before. I got the standard member data there. Got those private member functions just to record the name, just to record the phone number. So got this, and let's go look at the application file here. Great, that couldn't be any simpler. So all it's doing is just making one single contact info called entry, calling the constructor that has 2 arguments, of course, passing in this name and phone number, auto record it, and then just print it back out by calling entry.getName and entry.getPhoneNumber. Just look back over here. Of course, those are the accessors here, get name, get phone number. Pass back character pointers. So let's see what happens. First of all, I'm going to compile this. Okay. Now I have my warning levels set pretty high in my compiler, which I like to be aware of problems as soon as possible. So the warnings I'm getting here is from this program, which really shouldn't happen, right? If you have warnings in your program, technically this did compile and it did make an executable right here, but I'm not happy about that because it's got warnings, so maybe when I run it, something bad's going to happen. So I try to not have warnings in my program, and even though this program came with the book, somebody kind of had an oversight there. So what the error is, ISO C++, that's International Standards Organization C++, forbids converting a string constant like this. It's a string constant, or sometimes I call it a string literal, forbids converting a string constant to a character pointer. and that's the type that's being received over here. That's a character pointer right there. Okay, that makes me a little uncomfortable. So the oversight is that, that is a memory location, right? The string's in a memory location. And the problem is if you pass it into a function as a character pointer, the function can change it. So this Kristen Lee in memory, that would kind of be pretty stinky if the function could change that string and I in the main function don't know about it. That's why that's not a good thing. So we actually know how to fix that. Is what they should have done over in the class is they should have made these constant character pointers. Okay, remember the constant tag says this will not be permitted to change. And now that's a lot safer, and our standards organization would be much happier with that. Of course, if I'm passing that into these functions, now I need to make these constant character pointers to be safe. Okay, and now I can save that. And back over here. So now that those are constant character pointers, they cannot be changed, and now everything will be more safe, and I can compile this, and I don't get any warnings. Okay, that's good. So now we know it's compiled. There's no warnings. That's as good as I can make it. There's the executable. Now I can run it. Alrighty. And what I normally ask my students in class at this point is I go, this program, is it working correctly or is it working incorrectly? And hopefully that you agree that it's working incorrectly, right? Obviously, the name Kristen Lee is fine. The phone number Kristen Lee, that doesn't make any sense. Okay, so this program wasn't actually tested and there's a bug somewhere in it. What's the problem there? Now we noticed this, right? We noticed it when I was reading a lecture is, I guess they didn't fix this. On line 31, you shouldn't be passing the name into the info phone function. You should be passing the P, which is actually the phone number. That's what you want there. Okay, so I make a little fix. I go back. I got to recompile it. Run it again. Still not working right. So I think it's because this object file is still sitting there. Is that the deal? Sometimes that happens there. So I think what I need to do is rebuild all, right? So if this happens to you, try that. Try rebuild all. Okay, and I just saw there that it rebuilt the header and the object file that it needed. And now when I run it, now it's actually working correctly. Okay, so again, we have these dependencies, right? I have these multiple files, and the problem was when I hit compile, remember we said it's only going to compile the files that you changed. So the fact that it did not change the application file here, program 1312, I didn't change that. It didn't bother to rewrite this .o file. And that was a problem because something that this program depends on, namely the header file, that did change, but that wasn't handled automatically. So I had to rebuild, I had to tell it specifically, you better go rebuild the .o file because the definition of this class has changed, specifically over in that inline function. Now, I guess that might be an argument not to use inline functions, because if you had the function implementations in a dedicated source code file, it would have known, obviously, source code files changed. I know to recompile that. But with all the inline stuff in the header file, that got a little bit tricky. So sometimes you might need to do that. You might need to hit rebuild all, and then it does actually recompile every single .o file, and you'll catch anything that changed. Okay, so that finally works. Now, let's try running this through the debugger just to be absolutely sure about how this works. I'm going to hit a breakpoint on the very first line, like I like to do. Start running this. Who knows what else we're going to run into? Get a little bit more space on screen. I guess I need the debug tab. Do this, make this a little bit smaller, hopefully. That's as small as it wants to be. All right, so let's see. So here I am making an object. And we know that when you make an object, you automatically jump into the constructor. So I'll hit into function. And now what you're going to see is I'm going to jump over to the other file. So obviously the code for the constructor is over in the other file. So I hit this, I'm going to jump over to contactinfo.h, where this code is, in the constructor. Now this turns around and calls init name. So when I click into function, I jump up into that function. Great. And of course, this object has a couple pieces of data. It's got the name pointer and the phone pointer. I'd like to keep an eye on that. So I'll put watches down for name and also for phone. And you can see that these pointers, when the object initially gets made, they actually are set to 0, or in other words, the null pointer. Printed out in hexadecimal, of course. So these things are currently the null pointer, not pointing at any legitimate location. But when line 16 runs, you call new, and now, okay, so now you've allocated memory on the heap, and Windows came back and said, here's the address of where that array is. So now I have a legitimate address, right? This array got put down in the heap at hexadecimal 1F12CO, but the contents of that array are a bunch of random garbage. So here's a bunch of random characters that were just sitting in those bits. Doesn't make any sense here yet, but at least I have the space and a legitimate pointer. And now when I run line 17, it's going to copy in the characters from Kristen Lee to this array. Let's see that happen. And now that array is actually holding Kristen Lee, having copied that string in. So similar thing here. Here's the init phone call. I'll go into that function. Right, phone's currently the null pointer. Allocate an array. Store the address here. Right, that's at address hexadecimal 1F12E8. It's got a bunch of random garbage in those bytes, but when I hit string copy, we'll copy in the phone number over there. Now to be careful here, because this is the end of an inline function, it's just going to want to jump back all the way back to the main function. I'm going to hit next instruction. So I'm doing individual assembly language instructions here so I can see all the little steps. In our program at CUNY Kingsborough, this is CS 1400 stuff that I'm interacting with here just for a second. Assembly language stuff. So doing the string copy, and here, there's the phone number, right? Got in there. Right, okay, so now we're coming out of that function, and we're back here. The constructor is wrapping up, so that'll send us back to the main function over in the application. Now you see, now that I'm back in the application, that member data is out of scope, right? That stuff's private, so I'm not allowed to see it, and it just scrubbed it out of the debugger as well. So if I wanted to know about name and phone, the current stack frame, the function that I'm in right now, does not contain any variable called this. And that's actually a little detail that we'll talk about sometime in the future, but not right now. So the constructor is done. You have legitimate information in the object, and you call entry.getName and print that out. And you call entry.getPhoneNumber, and that gets printed out. So all that data was successfully stored. You call return here. And I guess let's see if we can jump in there, right, into that function. Because don't forget, here, you're calling the destructor. So as you return from the main function, that object's getting scrubbed out of the memory, calls the destructor automatically. Here we are here. And of course, you're going to delete the name array, and you're going to delete the phone array. So there's no memory leak. And you come back here, and the main function and the program wrap up, and you're done. Nice. Okay, so I think that's kind of good to see exactly the order of operations happening with that constructor, sending you to the helper functions that actually, you know, create and copy the actual information. And one last thing. So if I click over to the classes tab, right, I can see the contents of a contact info class that's over in the other file. And as usual, it's listing all the different functions, right? It's listing the data that's marked private. Also these functions. So let's say, you know, I'm working as Bob. I want to add something here. Let's say I want to change the name of the person involved, right? And Bob knows about structures. He knows about members. So he wants to change this to John Smith. And what he's going to do is an entry dot, let me see, there was an init name, right? Init names the function that takes a C string for a name. So init name, pass in John Smith. There we go. And we compile this. Well, no, that's not permitted because, again, init name is private, right? That's the whole thing about private, is that you're not allowed to access it in the application any place that's not inside a member function. So once again, we're getting a similar error before. That function, the void function that's in contact info called init name, well, that's private within this context. We're working outside of the object, and that is simply not going to be permitted. That's what it means to have a private function. So it's something that needs to happen inside the object, specifically when it gets constructed. Of course, you have to allocate memory and copy the information over, of course, but it's not something that the application programmer needs to worry about or know about, and in fact, they're not permitted to change the name. It's kind of a security feature that for once you've constructed one of these contact info objects, the way this is set up, you can never change the contents. You're not permitted to change the name. You're not permitted to change the phone number. It's actually impossible. They didn't give you any public mutator with which to change that stuff. And sometimes you want your objects set up like that. That's called having an immutable object. Once you construct it, that information is fixed and unchangeable. And we made that happen by not giving any public mutators and making those init name, init phone numbers private. So, you don't do this all the time. You do this sometimes, and sometimes you make your objects immutable for security purposes. And again, the other application programmers don't have to worry about changing the information. In fact, it's impossible, as you see when we try to do it right here. And that's what a private function is for, those kinds of tasks. I like that example a lot. We had to fix some stuff about that, but nonetheless, I kind of like that example. All right, so second thing for this video, arrays of objects. You're probably not going to be dealing with just one object of a particular type. You're probably going to need a whole bunch of them, 10 or 100 or 1,000, whatever. So of course, you need to put objects in arrays. And objects can be elements of arrays just like integers can, just like structs can. It's going to look almost exactly the same as structures in an array. Now, the wrinkle here is, remember that when you make a new object, the constructor runs, and you can have overloaded constructors depending on what the programmers want to set up initially for their objects. So we might have 1, 2, 3 different constructors, and the little wrinkle here is, how do you pick which constructor you want to run in your big arrays of objects? So we'll see a couple different ways of doing that. On the next slide, we're going to see an example of a class that has 3 overloaded constructors, kind of like we've seen before. We'll use that as an example. So here is inventory item.h. Here's the header file to a series of programs that the book uses for this. The class is called inventory item to store everything you need to know about one particular object that's for sale in a store, maybe like a hardware store. So the private data, you have a string, a C++ string for the description of the item. You've got a double floating point variable for the cost. You've got an integer for the number of units that are currently in stock in the store. This is the kind of thing we've seen before. But now here comes some constructors. It has 3, right? Line 15, you have the default constructor that takes no arguments. So that's what usually runs by default, as we call it, if you don't put anything else down. And this one just fills in dummy data to make sure the variables aren't uninitialized. Fills in an empty string and 0 for the cost and 0 for the units on hand. Great. On the other hand, here's constructor number 2 that just takes in the name of the item. So in comes a string for the description. You set the description of that. And to begin with, you set the cost to 0 and you set the units on hand to 0. Those will get filled out maybe later on. And then here on line 31, here is the third constructor that does actually take in data for all the members. So a string for the description, a double for the cost, an integer for the number of units, and all those things are recorded in the 3 member variables. Okay, and again, I could imagine different programmers, Bob, Kathy, Dennis, wanting to use any one of those. Bob comes through and he wants to do the bare minimum amount of work. Kathy comes through and she just wants the name to begin with, and she'll deal with the cost and the units later on. And here's Dennis, and he has all that information available right now, so we might as well fill that in. So again, the question on the table is, if you make a big array of objects, and your store is going to have a whole bunch of inventory items, how do you pick which of the 3 constructors you want to happen? So 3 different ways of making that occur. Item number 1. If you just want the default constructor to run, you don't need to do anything. So here I am making an inventory item array. It's called inventory, and it's size 3. So you just made 3 inventory item objects. And if you just do this with no other typing, the default constructor runs on object number 1 and number 2 and number 3. Again, the constructor runs for every single object automatically. You can't even avoid it. And in this case, it's just the default constructor, which in our example fills in all zeros in a blank string. Now, if you want to call a one-argument constructor, that's really, really simple. You just use a normal initialization list like you're dealing with an array. So here we're doing that. This would be Kathy's intent. So Kathy's making an inventory item array, again, calling it inventory, size 3, and she's doing the normal job with an initialization list looking like an array. So she's got a string for the first one, hammer, string wrench for the second one, string pliers for the third one, and those 3 strings say, hey, you better call the constructor that just takes one string, and the first object gets hammer, and the second object gets wrench, and the third object gets pliers. Okay, but again, that only works for a constructor with just one argument at a time. Now, if you're in Dennis's situation, and you do want to call the constructor that takes more than one argument, he's got to do this. So you give it an initialization list, but the items in the initialization list look like explicit function calls to the constructor that you want. So again, he's made this inventory item array, and the first thing in the initialization list, it says inventory item hammer 69512, right? That is an actual function call to the inventory item constructor that takes 3 arguments. And that's what that looks like. So you call this, it actually makes a new object with that data, and that's the first thing in the array. And here is the explicit constructor call to the constructor that has 3 arguments for the second one, and here's the explicit call to construct the third object in the array. Okay, so these first 2 kind of look like old hat to us. This last one is the one that's really new, is you're actually going to see explicit function calls for every single separate object in the array. And you can do that. And again, for Dennis's situation where he really wants to specify every single piece of data initially as he makes the array, then he's got to do that. Now, of course, it's not like Bob is wrong. So if Bob is going to get user input later on, or he's going to read in information out of a file, right? He can fill in all those fields later on. He doesn't need them to be initialized when the array gets created. But I guess that's what Dennis wanted. And of course, Kathy just wanted the names in there to begin with. So 3 different options depending on whether you want to call the default constructor, which usually does nothing, or a one-argument constructor, or anything other than that. You have to do the one that's on the bottom. So take a look at that. All right, now, of course, hopefully you could just fill in the slide on your own. Once you've created the array of objects, you access the stuff in them with subscripts and dots, just like you did with structs back in chapter 11. So we're just really building on structs. So once you have that, you identify objects in an array with subscripts. You say, do I want number 0? Do I want number 10? In brackets, of course. Then there's a dot, and then you can call your public member functions after the dot. So in that example just before, here I am looking in the inventory array, looking at element index 2, okay, in brackets, then dot calling the set units function. So presumably there's a setter for that. Like this is what Bob would have to do, I guess, setting the number of units in that particular object to the number 30. Okay, and then on the other hand, to get information out, we're doing some counting, inventory, name of the array, here's a subscript, number 2, here's the dot, what public function you want to call in that object, and here you're calling get units to report back the number of units and get it on the screen. Right? So very similar to what we do with the structs, it's just now you're not getting the individual data, you're getting the public functions, because that's how object-oriented programming works. But as usual, name the array, dig into the particular element, dig into the particular member function. So there's a program that does this whole thing. It's not that long. I'll let you look at it on your own. Program 1314 makes an array in that third case, right? Does fill in all the information to begin with, like Dennis has to do, and then just has a loop that calls the getters and prints all the information back out. You got to take a look at that, make sure you can do that. It's new, but it's important. And here's the third thing today is, of course, you can use pointers to objects. So here we are defining a pointer to an object, that line right there. The type is rectangle pointer, and the name of that variable is our pointer. So to be clear, that is not a rectangle object, right? It doesn't have a whole bunch of separate data. It's just like on my system, it's 164-bit number about where there's going to be a rectangle somewhere in the memory system. Right? It's not a rectangle, it's a rectangle pointer, which is different. So having done that now, if I do actually have a real rectangle object called other rectangle, I can get the address with the ampersand operator, of course. Right? I can store that address in our pointer, that's what it's for. And then once I have that pointing at a legitimate object, then I can start accessing the public member functions with the arrow operator, as you do with pointers to structures. So here we're doing our pointer arrow set the length of that rectangle, passing 12.5 for that. On the other hand, here we are getting the length with our pointer arrow get length. Okay, so pointer to a structure or an object, that's what the arrow does. Don't forget, so our pointer arrow get length. So again, that's really just shorthand. You could have written that, let me think here, parentheses, star to dereference, our pointer, close the parentheses, dot, get length, right? That's really what you're doing there, but don't do that. It's so ugly. It's just so ugly on the screen. Don't do that. Use this arrow instead, just like we did with structs, with pointers to structs. So here's my pointer to a structure or a class. Here's where it is in memory. Go look at this particular member function now. That's what you want. So of course, you know what's coming next. If I can use pointers to objects, well, that means, the thing that you're probably going to really want to use pointers for is dynamically allocated memory. Of course. So here's an example of that. On line 2, we're declaring a rectangle pointer. We're calling it rect pointer. That's actually a pretty common name. And we're initializing it to null pointer. Remember, that's actually the number 0, which marks this pointer as not actually pointing to a legitimate rectangle yet. So again, we didn't want an uninitialized pointer, which is called a wild pointer. And if you start using that, now you're really in trouble because now you're scrambling up unknown parts of memory. So you don't want uninitialized pointers, and we're avoiding that here by setting it to null pointer. Now that's going to change on the very next line for what it's worth. So on line 5, we're allocating a brand new rectangle somewhere on the heap, however big it needs to be, getting the address, storing it in rect pointer. So rect pointer isn't null pointer anymore. Hopefully it's an actual legitimate location. And now we're just going to test it. We're going to call the setters with rect pointer arrow set width and rect pointer arrow set length. Just to do some stuff, and you could call the getters and you could print it out. You can call the get area, of course, is what we have in there. And then at the end, don't forget, if you dynamically allocated the rectangle, you need to delete it at the end. And then the book does this thing to be really just super, super, super careful. They reset the rect pointer back to null pointer just in case somebody comes through later on and tries to use it because it's deleted and it wasn't really there. So that's why they're doing that. And remember, we'll probably say this a couple times, is when you create a new rectangle on line 5, that calls the constructor. Of course, don't forget about that. And when you delete it and throw it away, that calls the destructor in the object automatically. So you might be dynamically allocating an object, like maybe the contact info object that we've seen before. And that object, you call the constructor, that constructor actually itself triggers more dynamic memory allocation inside the object. Okay, and so here, when you get done with it, you got to call delete. That calls the destructor, and then inside the object, that itself deletes the memory that it was controlling. So you might actually have this chain of dynamic allocation in the constructor, calling more, and then this delete, which triggers the destructor, triggers more deletions, which triggers more destructors, which causes more deletions in possibly a chain. But fortunately, again, the application programmer doesn't need to worry about any of that because all that's just happening automatically. A lot of work happening under the hood that we're not even seeing, which is good because I don't want to deal with that stuff. Okay, so here we are emphasizing that on this slide. So remember, when an object is dynamically allocated with the new operator, its constructor executes. So in that example, we were just calling the default rectangle constructor, the one that just sets length and width to 0. So if you wanted to, you could call one of the other constructors. Right? In the past, we've seen rectangle with no argument, with one argument, with two arguments. So here we are dynamically allocating a rectangle on the heap and calling the 2-argument constructor to pass in 10 and 20 for the length and width. So as it gets created in memory, it automatically has the 10 and the 20 in there to begin with, because that's the constructor that you called. Great. And when the object is destroyed, the destructor executes. So if you did this to begin with this rectangle pointer called R, when you call delete R, you don't see it, but the destructor automatically gets called in that object when you delete the object. Great. Okay, so all that stuff gets cleaned up just as soon as you call delete. That's what you want. A lot of work being done. Okay, so in this video, we saw private member functions for functions that are handling internal procedures in a class that the application programmers really don't need to worry about. We saw pointers to objects that, of course, you're probably going to use for dynamically allocated memory is probably the most common thing you need that for. And possibly most important of all, we saw arrays of objects. You know, real-life programs are handling lots and lots of data. You're probably not going to see objects just one at a time. You're probably going to see them in an array as you handle lots of data. So we should practice this. And when I get together with my students next, we'll be doing this lab on arrays of objects. Want to get as much practice at this as possible. You want this to be very, very comfortable creating arrays of objects, manipulating arrays of objects, passing them into functions, stuff like that. It's almost no different than structs, but this is how you're commonly going to do it. So ought to be very, very well practiced at this. We get this inventory.cpp lab, and it has a class for inventory items, pretty much like we saw in the lecture. You're running a store. You're not just selling one item, obviously. You've got a whole bunch of items, so you need an array of these inventory item objects. And we need to get all that data to test the program, obviously. So fortunately, this lab provides a data file called inventory.dat. So now that we're after chapter 12, we get to use file handling, and this program is just going to suck in all the data for the entire array automatically from this file. And I'm very happy that we finally got past chapter 12. So now when we're testing our programs, when they're using a lot of data in a big array, we don't have to sit there and keep retyping the user examples over and over again. We can just get it in from the data file like this. So this will make our testing a lot more efficient, I think. And of course, you know, I guess another way of looking at this is that we get more practice with file handling, I guess is another way of looking at that. And, you know, I guess this data file has 10 items, but this program wouldn't work any different at all if it had 100 items or 1,000 items, because the file handling would just read it all in and write a report about what's currently in stock on screen. And I think that's a pretty good example there of using objects in an array. That's certainly something you'd want to do. Couple of things there that I rename a couple things because I think it was like confusingly named in the code. So I do a couple edits before we get started there, but that's that. Okay, so pretty good package that we have together for initial object-oriented programming here, pretty close to the end of chapter 13. We'll see more in future chapters, of course, but that's a good starting point. Now in the next video, there's one more video in chapter 13 that's a little bit different as we think about what tools are there for conceptually thinking about design for a bigger program that uses objects. Maybe not just one class. Maybe you've got 2 or 3 classes interacting together. The programs will start to get larger, of course. I have students that start asking me, I don't know where to get started. How do I know where to begin programs that are as big as what we're working on right now? So that's what the next section is about. There's a design tool called UML, or the Unified Modeling Language, which are how you sketch out, you visualize objects, visualize interactions between objects, and there's something you'd sit down with your team in advance and a whiteboard, and you'd plan out what objects do I need, And there's a particular graphical technique that we use, again, called UML. So that's important to have those kinds of design support tools as we start working on larger object-oriented programming. And I hope that you'll join me for that. I'll see you then.